Hey everybody, were you starting without me? I guess it must be time for math with Mr. Troy. Alright, so we're going to do something a little different today. Tomorrow's just a review and catch-up day, or today, or whenever you're watching this, maybe several weeks ago, I don't know. Just to make sure that we're all on the same page, so I thought we'd do something a little different. This is a question from the test that I gave last year, which obviously will be different now because, well, you know. And I just wanted to work through it and kind of think about how I think about it and all that good stuff. Let's go. So g is a fourth degree polynomial that has rational coefficients that has two known zeros. 1 plus 3i and the square root of 2. Now, based on kind of two things we know, if it has rational coefficients, rational implies real as well. So that means that 1 minus 3i must be another 0. And then the only way to get rational coefficients is if we take our square root of 2 and we have as another 0 the opposite of the square root of 2. So in order for us to be able to use an imaginary number or an irrational number and not have that give us, irrational or imaginary coefficients, is that we have to use their conjugates. So the remaining zeros here are 1 minus 3i and the opposite of the square root of 2. Okay, fourth degree polynomial means that we need to have these two and those two to make 4 total. Okay, now the next part, find two quadratic functions that are factors of g of x. Use the given zeros and those from part A. So basically, we need to find some x squared blah 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 times some other x squared blah 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 to get our x to the fourth blah blah blah, which by the way is part C. So how would we find a quadratic using this information? Well, if the square root of 2 is a factor, then x minus the square root of 2 is a factor. And if x, if the opposite of square root of 2 is a factor, or is a 0, oh boy, then x plus the square root of 2 is a factor. So when we FOIL that out, we're going to get x squared minus 2. So by using these, kind of irrational conjugates, we might call them, by using plus or minus root 2, it makes it so that we don't have any root 2's in our quadratic there. So let's do the same thing, except we'll do it for x minus 1 minus 3i and x minus 1 plus 3i. Okay, there are like a billion different ways to do this, so I'm just going to give you, one of those ways. Whoa! Hey there. I think, people get tied up in thinking there's only one right way to do something, so let me show you just one way that we could multiply this, and we did a different way in class, so hopefully you saw that, I guess. Okay, so think of this as something to FOIL. Think of it as x minus a times x minus b. Here's the a, here's the b. A and b are really close to being the same thing, but not quite. So if we were to FOIL that out, we would get like, x squared minus ax minus bx plus ab, or something like that. Like that's how that would FOIL. So let's give that a try. So x squared. We're off to an easy start. Then, if I do my outers, x times 1 plus 3i, I'm going to get, x times negative 1 plus 3i. I'm going to get negative x and negative 3ix. If I do the same thing here for my inners, I'm going to get negative x and positive 3ix. If you're confused about those signs, you could distribute this negative into the parentheses. And then finally our lasts. So what happens when we do 1 minus 3i times 1 plus 3i? Or if you want to think of it this way, the opposite of that times the opposite of that, it's going to work out to the same thing. Well, that would give us 1 minus 3i squared. Or 3 squared, I squared. 1 minus 9i squared, or 1 plus 9, or 10. So we're going to get x squared minus 2x plus 10. Hey, I'm over here now. So x squared minus 2x plus 10. There is absolutely a shortcut to figuring out what this quadratic is going to be based on what this 0 is, but I don't want to ruin it for you. It's like way more fun to figure it out yourselves. Okay, find one standard form polynomial that could be g of x. There are many answers. We're just going to multiply these together. And when I multiply those together, I'm going to get x to the 4th minus 2x cubed plus 8x squared plus 4x minus 20. Now the reason that I say that there are many answers is also any constant multiple of this would work as well. So if I did 2x to the 4th minus 4x cubed plus 16x squared plus 8x minus 40, that would also work. All right, everybody. Hope this video was helpful. Have a good one, and see you later. And here comes the theme song. Hey, that's not where that's supposed to be.